a little bit longer, see if a few more people pop in, wait for, oh, I guess our last panelist did show up. So maybe let's get started. Hi, everyone. Welcome to our webinar. I'm Professor Wirtz, so I'll give you a short presentation of our department, after which we'll have a Q&A session with the panel you see up here in the videos. But before we get started, we'll have a few words from our department head, Professor Meunier.
Thank you very much, Esther. So I hope everybody can hear me, yes? So welcome to this webinar. Usually we like to see people here on campus, but well, we all know why we can't do that this year. So we are going to try to give you kind of a sense of the information we usually give, and that's usually the information that convinces students to come here. So I'm the department head here, even though I'm going to let Professor Wirtz run the show, as she usually does perfectly well. And I'm going to be just here to answer questions at the end or at any time. And also, if you have specific questions, remember that we have this one-on-one meetings that you can set up. You got a link to do that. Please do not hesitate. There are many slots that are open, and because there were many slots to start with, so we'd be very happy to talk one-on-one with you. I think most of the dates are for next week, so please do so. Just check in the email that you receive from the physics department. So people who are on the panel today, so aside from Professor Wirtz, there is also, so Professor Wirtz she's an expert in experimental optics in general. There is Professor Martin, who is an expert in computational astronomy, should I say, something along those lines. He's also one of our top teachers here in the department. There's Professor Terrones, who is a world expert in material science, material physics. And we have, I think, Professor Wetzel. I don't see his camera on, but he's also doing semiconductor research, and he's going to be here on the panel. And last but not least, we also have two of our current students here. And this would be Sophia and Nigel. So we did not train them for this. So they are going to be as candid as it gets, and there's no way for us to stop them since they are so far. But they will at least give you an idea of what's happening, and they are not known to be shy, so don't hesitate to ask them questions that they will answer the best they can. They just finished the exam for quantum mechanics, so they feel really completely delocalized in space, which is great. So I think I said I would talk 1 minute. I probably already at 2. So I'm going to stop here, but please do not hesitate to ask us any questions. Sometimes people are a little bit shy to ask questions in front of everybody, so please do not hesitate to send email or to sign up for a one-on-one discussion now that you kind of know the people who are available for this discussion. So that's it. So Esther, the floor is yours.
Thank you. All right. So just as a reminder for everyone, I'll give this short presentation just to give you an overview of our program and the department. But feel free to ask questions in the chat while I'm talking. The other panelists might answer those questions directly as you ask them, or we'll answer them verbally at the end of the presentation. All right. So as Professor Meunier said, we're the Department of Physics, Applied Physics, and Astronomy. Our main goal is, or one of our goals, I suppose the most obvious one, is to teach you physics. So we teach a number of physics classes, both in the core subjects and a number of electives. And we teach introductory physics classes for all majors as well. But I would say overall, what we're interested in is trying to teach you critical thinking and problem solving skills that will then allow you to be successful in whatever path you choose to go to after you graduate. So in our program, we have a Bachelor of Science in Physics and in Applied Physics, and I'll tell you about the differences between those two programs in the next few slides. We offer minors in Physics, Astronomy, and Astrophysics, so if you have questions about astronomy and astrophysics, Dr. Martin will be able to tell you everything about that. And we have a graduate program in physics, so both a master's and a doctorate in physics. So here's maybe something that you'll be very interested in. So it's our template for the physics program. It illustrates some of the classes that you would be taking at our PI. When you join the department, you and your faculty mentor that you'd be assigned will discuss the best program for you, depending on your interests and number of AP classes you've taken beforehand. But this gives you an illustration of a typical schedule for a typical physics student at our PI. So in green, you have all of our core physics classes, so these would be required. We have the honors physics sequence, in which you would go into maybe some of the concepts that you've already studied if you've taken AP physics classes, but in much more detail. Then we have our quantum physics series in the second year, theoretical mechanics, which is one of our first upper level physics courses, or more in-depth physics course that Professor Martin teaches, experimental physics, where we hope to give you a taste of the awesomeness of experimental physics. And then our trifecta of upper level physics courses, so thermodynamics and statistical mechanics taught by Professor Toronis, electromagnetic theory that I teach, and intro to quantum mechanics that's taught by Professor Meunier. In order to be successful in physics, you need a good sort of understanding of math. So we have a number of required math courses in blue, some required science courses, so computer science, biology, and chemistry, some humanities or social science electives here in this pinkish brown, and then electives where you can sort of investigate new subjects that you're interested in. And then, you can fill in the blanks with whatever else your passion you discover. The applied physics program is identical in the first couple of years. There are two minor differences and one major difference with the physics program. The minor differences are there's one fewer math required course, and you're not required to take intro to quantum mechanics, but obviously you would want to take it anyways because Professor Meunier is a fantastic teacher. The main difference are these purple boxes where you would have these 16 credits of what we call technical elective. And this gives you an opportunity to really delve in depth into a subject of your interest. And so this might be interesting to you if you want to pursue, go to graduate school for a subject that might not be physics, so let's say material science, or if you want to work in industry in a field that is maybe not obviously related to physics, so let's say data science. So these would be, this would be a way for you to say on your CV, I have the physics background that gives me critical thinking and problem solving knowledge, and I'm also, I've delved deep into some subject that you're interested in. So that could really be anything. It could be something like computational physics, optics, electrical engineering, sustainability studies, really whatever strikes your fancy. So if you have more questions about that, we can answer them at the end. One of the aspects of our program that we really are very proud of is undergraduate research. Most of our undergraduate students join a research lab at some point in their career at our PI. I would say, I'm pretty sure it's accurate to say that all of our active research faculty have undergraduate students doing research with them. I currently have 5 undergraduate students working with me in the lab, although right now they're not in the lab because I don't have access to lab, so we're finding some other ways to do research. But in normal times, the undergraduate students have access to my lab and can do research with the graduate students of my lab as well. So this is really an important part of our program, and we really encourage you to participate in this aspect of work at RPI. So after graduating, there are a number of paths that you can follow. So very often, prospective students ask us, what can you do with a bachelor's in physics? So the obvious next step is to go to graduate school. And so a third of our graduating physics students go to graduate school in physics. A third of our students go to graduate school in a field other than physics. And then they go to some of the top universities in the country and abroad, so Caltech, MIT, Harvard, University of Michigan, University of Paris, et cetera, et cetera. But a third of our students also go and find jobs in industry. And so here's a list of some of the places that our students have been or are currently employed in. So GE, IBM, Boeing. Companies are usually very interested in hiring physics students because we're good at solving problems. So if you are unsure of whether you want to study physics because you're not sure of what the opportunities are after you graduate, there are plenty of opportunities, and we'll be happy to talk more about that during the Q&A session. Okay, so beyond the classroom, there are a number of opportunities open to you as well. So something that's very dear to my heart is the Women in Physics group. And so Sophia, one of the students on our panel, will tell you a little bit more about this now. So Sophia, if you want to turn your...
Hello. So I joined Women in Physics as a freshman, and as in your first semester, you have the opportunity to get paired with an upperclassman, and this is super useful because it's the first step to a support system, and as well as making friends. And the further you go in your careers at RPI, you have opportunities to not only become the mentor yourself, but also reach out to the local community. Like in the Troy High School and Middle School, we do outreach programs, and also to Girl Scout troops in the surrounding area. And another club we have here, or I guess it's called the Society of Physics Students. Many of my friends are in this club, and we have one of our panelists, Nigel, will tell you more about that.
Hello. Okay. So SPS, unlike WIP, is kind of like it's more of a hybrid club between social events and also academic opportunities. So while in WIP, it's more of social discussions and pairing up with mentors and stuff like that. SPS does have that, and we do have some academic stuff with it. So on the social aspect, we usually have weekly movie and pizza nights. So that's usually when we get together normally at like 8 p.m. on a weekend, and we make fun of bad movies, which is a lot of fun to do with each other. And we have some reoccurring events throughout the year. So in the fall semester, we held a Smash tournament, which was a lot of fun, and we had a holiday party at the end of the semester to celebrate finals being over and going home and stuff like that. But on the more academic and technical side, SPS has something called the Build Team, which is what I'm the leader of, yeah, I guess am the leader still, even with the events going on. Where and Build Team is more in charge of actually building physics demonstrations and going on outreach events. So had this accepted students day not been online, we would have a big room set up in the physics building where we would have all these demonstrations set up, and a bunch of students from the build team would be there running them and showing you what kind of physics you're going to learn at RPI, what kind of experiments you'll be able to do, and kind of things more in that nature. And then along the lines of that, SPS in general, we were going to start going on outreach events as well, where we bring demonstrations to other local communities. So local schools, like middle high schools, we were reaching out with the Boys and Girls Club of Troy, New York. But and we were going to partner up with WIP to work on a Girl Scout Day badge event. But unfortunately, all of that has been canceled. But we are going to try to keep doing that in the coming semesters. So that's something to look forward to. And before we move on to other clubs, I'm going to quickly sidebar the discussion really quick. So I know like one big challenge with choosing which college to go to is getting a feel for the social environment there. And a lot of people some of us here at RPI, we were concerned that a lot of incoming freshmen aren't going to get that that exposure to other students, and will they fit in and things like that. Because I personally have a few friends who actually chose to come to RPI specifically for the people that were there and the social feel on campus. So as a result of that, we invite all of you guys in the webinar now to join the RPI Physics Discord server. So I'm going to put the join link in the chat now if you want to hold on to it. So there is a big discussion with, I think we have about 350 physics majors on the Discord now. And feel free to go there to talk to each other, ask questions about to other current students that are here that might have a more breadth of experience than just Sophia and I, because it would be a disservice for you guys not to have as much information as you could before you choose. And in fact, a lot of faculty members are also on the Discord too. I don't know if it's set up such that you could ask them questions, but we'll work on that later. So close parentheses, sidebar over, back to clubs. So if Society of Physics students or Women in Physics, if those clubs aren't interesting to you and you're more interested in astrophysics or things along those lines, Professor Martin runs the Rensselaer Astrophysical Society, or RAS, and he'll talk about that with you guys now.
Hello, hopefully everyone can hear me. As Nigel just said, thank you, Nigel. I'm one of the faculty advisors for the Hirsch Observatory, located on top of the science building at RPI. In the pictures on this slide, you can see the outside of our observatory building with the dome, and the bottom picture shows you our largest instrument at RPI, the 16-inch Bowler and Chivens telescope, built in the mid to late 1960s and donated to RPI in 1980 by GE. The club is in session the entirety of the school year, and we hold public observing events which are open to the general public and free of charge 10 months out of the year. So starting early in February, running all the way through the end of November, the observatory is open from 8 to 10 p.m. and is the largest part of the outreach that the club does. The club is responsible for running, maintaining, and taking care of the observatory in these aspects. Additional contributions include an 11-inch telescope, which the club recently purchased in the last 2 years, a very nice 11-inch teeter telescope, and a donation from a very generous alumnus of a pair of Fujinon 25-time magnification binoculars, which are enormous and fantastic and a great opportunity. Students join the club, they're trained how to use the equipment, they're trained how to use the telescope, and then the culminating result is, once you've shown us that you know what you're doing, you get placed on a key list so that you have access to use this observatory whenever you like. So you can go up with a friend, you can show them how to use the telescope, you can take images with state-of-the-art CCD cameras that are available at our facility. So it's a fantastic fantastic opportunity for students who are interested to actually get to use larger telescopes and some CCD equipment that you might not necessarily have access to on your own. So it's a great opportunity. I believe at this point we're going to pass it over to Professor Turonis, and he's going to talk about the supercomputer.
Hi, hello everybody. I will talk about the supercomputer we have at RPI. We have upgraded our supercomputer. This was upgraded in November. RPI and IBM collaborate together. And we have had in the past, I don't know, more than 10 years, very good supercomputers. The one we have now is 24th in the world, and you can check this in the web just by typing top 500 supercomputers. The one we have has 130,000 cores, which is very good. And what is more is that our students, undergraduate and graduate students, have access to this supercomputer. Now IBM and RPI are very interested in artificial intelligence. Is very important. It's a hot topic now, artificial intelligence and machine learning. And the faculty at the physics department also are interested in doing machine learning and artificial intelligence. So I think this equipment, this supercomputer, and access to it offers new possibilities in RPI that other universities may not have. Thank you very much. We are about to end. Perhaps Esther can take the control now. Thank you very much.
All right, yeah, so just to wrap up, so you got a quick overview of some of the opportunities available through the physics department, but there are all sorts of other clubs and organizations available on campus. So in fact, apparently over 250 clubs sponsored by our student union. Obviously, there are sports, community service projects, ROTC. As I said earlier, undergraduate research is a huge part of our program and programs in other departments. Though actually I should mention that you do not have to do, you're encouraged to do research, and you're not required to do that research project within the physics department. If you find an advisor that you're interested in working with that's outside of physics, that's absolutely possible and highly encouraged as well. We have a few study abroad programs and some co-ops and internships. So with that, I'll